Yes, sir.
So I'm starting. So now we'll start with the IP address part. And already I told about IP address and MAC address. Just a small recap. Okay. But there is a question, important question is there. What is an IP address?
Hello, sir.
Oh, tell me. Ajay, tell me, you can tell, speak. Okay. Guys, as I said earlier, so that is every device must have an NIC. Every device must have
Hello,
an,
sir.
yeah, tell me, Ajay. So, happen, no problem. Okay. Every device must have an NIC to connect in the network. Every NIC has a MAC address. This MAC address, we call it as a physical address. Okay. The MAC address is in binary, it is 48 bit, but actually we write in the 12 hexadecimal. The MAC address we are not assigning, it is already assigned by manufacturer of that NIC only. We can't change the MAC address, but there is a MAC spoofing is possible and a MAC binding is possible. Okay, what is the use of this MAC binding? Look at here. So when in a Wi-Fi, wide is a secure network, direct wide connectivity. But in a Wi-Fi, any person can able to connect it to your Wi-Fi network with their mobile phone or laptops, so they can able to connect it to your Wi-Fi device. What they need, what is your Wi-Fi name and the Wi-Fi password. The Wi-Fi name we call it as a SSID. SSID means your Wi-Fi password. To connect it, we need a password. So Wi-Fi name is our SSID and we have to put a password. Request go to the Wi-Fi router. Wi-Fi router verifies your password and it will establish the connectivity. So you will get a IP address from your DHCP server, means from your Wi-Fi router. Okay, this is what it is connected. If you share your Wi-Fi password to anyone, okay, what will happen? People knows your Wi-Fi router password, so they will try to connect it to you. Then what happen? More connections and compromise of securities, more load on your internet is there. So what I have done, I know the devices from whatever the devices we are getting connected. Mobile phones or laptops we are using in our network, in our office or in our home. I have something like a 10 devices are there. I will take all 10 devices, MAC addresses. I insert this MAC address information into this Wi-Fi router. Okay. So what will happen? Now remove all the connection. Okay. I have a 10 devices list. In the 10 devices, every device has their MAC address, right? Yeah, their NIC has a MAC address. I'll keep every device MAC address in the list. So I put that list into this Wi-Fi router. Alright, I will go to the Wi-Fi router settings. Then I will put a MAC address binding. I said to the Wi-Fi router, there is a configuration options are there. So I will tell allow only these particular devices only. So here is a device, put a password, password of my Wi-Fi password. So they will try to connect. So Wi-Fi router verifies your password. Yes, you are authenticated and verify in the list of MAC address. Yes, your MAC address is there. So you are allowed to get connected. Now connection is established. Someone who is not in the list, is trying to connect at us with a password. So they try to connect it. So our Wi-Fi is trying to authenticate. Yes, your username password is correct. The password is correct. You are authenticated, but you are not in the list. So no connection for you. You are not in the list. So you are not connecting. So Wi-Fi password is correct, and you cannot able to connect. This is MAC binding in a Wi-Fi routers. Okay. MAC spoofing. What is MAC spoofing? MAC, we cannot able to change our NIC's MAC address. You have NIC, the NIC has a MAC address. You can't change the MAC address. But you want to send a packet with a duplicate MAC address. Okay. Using certain softwares or programs. So while you are sending a packet, so you send your IP address and some different MAC address. So other person receive the packet, so they receive with a different MAC address, not your MAC address. That is MAC spoofing for usually for security purpose and attacking purpose also. Okay. And in other words, right, for my NIC, any broadcast message is coming. So NIC, what it will do, it will when it receive a packet in OSA layer, it verifies the source MAC address and destination MAC address. Destination not matches, drop the packet. In attacking array, collecting information, any broadcast messages it is coming, it accept whatever the packet it is. The later it will process it. Even for both places, for a securing and as well as attacking purpose, they use this MAC spoofing. Okay. But originally on your NIC, we cannot change our MAC address directly. Okay. Coming to the IP address, guys, IP address is a logical address. Identify a device, uniquely identified device in the network is our IP address. So what is an IP address? IP address is a logical address. It's uniquely identified device in a network. Every device must have an IP address to communicate in the network. To communicate in the network. Devices to communicate in the network, so it need an IP address. All communications by IP address only. For example, I want to ping to a device, or I want to access their web pages, or I want to uh, upload or download a file, I want to send and receive a mails. I use IP addresses only. Of course, you can doubt, sir, you open a website with a name. Of course, because I don't know the IP address of netattack.com and I don't know the IP address, and of course, name is very easy to remember. But there is a DNS server maps your name to IP address. So then we are getting IP address. Then we are communicating with an IP address. By display only it is showing IP name, but internally it is IP address only. Okay. And of course, we can assign an IP address or configure an IP address to our devices manually as well as automatically also. Automatically means by DHCP server. Okay. So there is a DHCP server and you have a devices. So devices need an IP address. Either you configured manually or you will get an IP address from DHCP server. Some people believes, okay, I don't know who created that believeness. IP address is by default in the device, it is already there. Means I purchase a mobile phone, it is already having some IP address. I purchase a laptop or a desktop, already it contains an IP address. Some people are putting this believeness. It is wrong, guys. I be there in the networking from last 10 years, more than 10 years, 2007 onwards. 2007 is my final year. So in a final year, second semester means 2007 December onwards, I am in the networking field. Okay. I start learning CCNA in my final year engineering itself. And never seen any device having its own IP address. The IP address has to be configured manually, means you open a network settings, you given an IP address, or you have to get an IP address from the DHCP server. Only two options. By default, there is no IP address in the device. Okay. You may get a doubt, sir. I don't have any DHCP server and I didn't configure any IP address to my mobile phone. Of course, you have a Wi-Fi router. Already I told this part, right? So, but I'm telling once again, refreshment. You are using a Wi-Fi router for your network connectivity. Your Wi-Fi router act like a DHCP server. I'm also getting an IP address from my Wi-Fi router. No separate DHCP server. So this is DHCP server giving me an IP address. Either you specially create one DHCP server in your network, your Wi-Fi router is also working as a DHCP server. Okay. Maybe you will get a question that, sir, I am getting in my mobile phone internet. So without IP address, I am accessing internet. Of course, guys. In your mobile phone, you are connecting with your 4G data, right? It means you are connecting with a tower for your signal and for a data connectivity. So you are connecting for internet when you open 4G data enable, obviously your 4G connection is established. Your towers are your service provider assign an IP address to you. You are device now having an IP address from your service provider. They are directly providing an IP address through these towers. Based on the tower and IP address, it is there. Okay. Now we got a point. Understand, guys? Okay. IP addresses can
Yes,
be changeable. Yeah. IP addresses can be changeable. Okay. We can change manually. You open adapter settings and you can change an IP address as per you like it. Or it can be changed automatically. How? Same thing, DHCP server. Guys, I connected in my office. I will get some IP address. I connected in my office. I will get some IP address based on my office Wi-Fi router or a DHCP server. If I take this laptop to my home, so when I went to my home and connected to my Wi-Fi router, I will get another IP address. If I'm not connected to any of network, I don't get any IP address. Okay, either I have to assign or maybe it has to get an IP address. Okay, it has to be connected to a DHCP in my network. If in my network there is a DHCP server and my Wi-Fi router has a DHCP server, then it will be changes. So what I said, I'm in my office. I got IP address from here. What are the DHCP server? I'm getting an IP address. So 6:30 office completed. I went to home. I reached 7:30, 8:30. Okay, I connected in my home Wi-Fi network. From there, I will get another IP address. So IP address can be changeable automatically by the DHCP server. Today, from DHCP server, guys, today I'm getting one IP. Tomorrow, I may get another IP address. May not be same IP address. Depends upon the DHCP server. Your IP address defines the logical network. IP address is defines the logical network. I have a lot of computers are connected in the network. Depends upon my IP address configuration. Depends upon my IP address configuration. I can say these devices are in the same logical network. Maybe these are all devices. I have 7 devices, all 7 devices in same physical network, same physical connectivity. By the IP address configuration, I can make this one as a different logical network. Depends upon my IP address configuration, I can differentiate the different network. Okay. So physically connected, but logically different networks it is. So how to define a logical network? Based on the IP address configuration. In our IP address, two versions are there, IPv4 version and IPv6 version. Guys, in a worldwide, we are using IPv4 only. Some people are more exciting people are there. India is a waste country. India, we are using still these technologies only. In other countries, they are using these technologies. They are having so many weapons. We are not having this one. Guys, this is nonsense. You are getting that information. Why? Because you say, take this IPv6 countrywide using very limited countries. Germany, for example, Japan, maybe one or two European countries may using this IPv6, entire country based on the entire country, their network. US using IPv4. Australia like a countries, Russia like a countries using IPv4, and because there are using very old routers, still IPv4 compatibilities only there. In certain private networks, for example, you take Geo fibers. The Geo is using IPv6. Geo using IPv6 type of network. Others may not use IPv6. There are still maybe in using IPv4. Okay, so that's the point, guys. It's not like that it is a country, India, but it is a worldwide acceptance is important. In certain private networks, certain countries that are using IPv6 100%. Still, there is a lot of countries and there is a lot of networks, lot of things still using a IPv4. Okay, so generally, main communication here we are doing all by IPv4 only, and of course IPv6 also there. Okay, so IPv4 to IPv6, no communication, guys. There is a converter from IPv6 to IPv4 conversions. So maybe like I have one IPv4 network and another one is IPv6 network. If they want to communicate, so one is IPv4 network. So completely this network is IPv4, another network is IPv6 network. You want to make a communication between these two networks, there is a converter, IPv4 to V6 converter, ISA tab servers, IPv4 tunnels, 4 to 6 tunnels are there. So these will make a communication between these two different type of protocol networks. Okay. Yeah, so this is a IPv4 is look like a in a decimal format only. So it's look like this, 4 parts, 192.168.11.67. Just for an example, guys, not only that, that is the one of the IP address from IPv4. IPv6 is represented in hexadecimal. Each number is hexadecimal number. It represents in a hexadecimal and it is very big one kind of stuff. Of course, next I will go to tell about IPv4, IPv6 anyway. So I told about IPv4, IP address and MAC address. Important is also there, that is differences. IP address is a logical address and MAC address is physical address. All communications by IP address only. To communicate in the network, compulsory we need to know the IP address of source and destination. Okay. So IP address can be changeable again. So logical address, physical address. IP address can be changeable. MAC address, we cannot change the MAC address. IP address is assigned by manually means by user or by you will get an IP address from DHCP server means assigned by automatically. But MAC addresses cannot assigned by anyone. It is assigned by manufacturer of that as NIC only. It is given by the NIC manufacturer only. Okay. IP address is having two versions. IPv4, which is 32-bit, IPv6, which is 128-bit in number. MAC addresses do not have any versions. It is only single version type only, and it is 48-bit in number. So these are the IPv4 to IPv6 differences. Okay, guys. Any doubts or any questions? Hmm? I have a meeting at 6 o'clock, guys. I have to close our session by 6 o'clock. Okay, so how much I can able to complete? Anyway, IP addresses is always take a two sessions, two part session. Because in one single shot, if I said IP addresses, so you will forget so many things. So you can see IP address part, IPv4, IPv6, IPv4 ranges, and the subnet mask, network and host portions, private IP address, public IP addresses, okay, NAT and PAT kind of stuff is also there. So remaining part, anyway, I will tell tomorrow, but basic part today, we'll try to complete it. Okay. But compulsory, guys, daily notes, you have to read it. Already you have a link of this diary regular notes. If in case, if in case your daily notes, you missed in this so many messages, I'm giving again that link. So you can read it. Okay. Compulsory read every day, guys. So practice how to tell an answer wise. You can do it. Okay. Once session is ended, completely your session is ended, you can see this batch 22 having so many pages. So it's not yet completed. So like that. So every data, every from starting to ending. So once your sessions are completed, you can simply download it also into the PDF format. You can download. If in case you miss it also, I will give you that PDF format. So it is like any time you can read it. Guys, daily if you read, so then you don't feel at the end of the sessions that something is done, something classes we are attended. We don't know what we attended. It's a common thing, guys, if you don't read every day. Daily read from starting to now. Daily. If you are getting 2 days time, so compulsory go through it. Put everything is a question wise. IPv address, MAC address differences, IPv6, IPv4 differences. What is IPv4? What is OSL layer? What are the 7 layers? Each layer data. Okay. What are the devices? What is their differences? What is a network? What is this one? Like that's if you keep putting question and how and answer practice. Guys, you're not a kids. We don't try to teach you as a kids. If we are teaching, if we are treat you as a kids, then we have to give assignments. Okay. You're professionals. You are done graduation. Whether it is BSc or BTech, I don't mind about it. Okay, you're professional, so you no need of these kind of assignments and all. So you have to prepare yourself. Of course, there is an assignments, but still you are preparing yourself. That is the point. Okay, so let's continue. IPv4, IPv6. IPv4 version 4, IPv6 version 6. And where is this IPv5? And what about other versions? Okay. So guys, it is a research like how to communicate, how to put an address in a communication. IP, Internet Protocol. It's a protocol. But what is IP address? It is an address for a device. So which defines in the device is in this particular logical network. Okay. Uniquely identification of device in the network. So people research what kind of IP address. Already I told IANA, ICANN is the responsibility of assigning this IP addresses. So when they design a IP address, so they got okay, good, this is useful. All testing is done. And IPv5, IPv6 came, there is a still research. So they released IPv4 earlier. So then now the IPv4 has a limitation. The limitation is completed. The next level is go to the IPv6 because IPv6 practically unlimited IP addresses. So many billions of IP addresses we are getting from IPv6. And compared to IPv5, so IPv6 is better. All tests are done. It is secure than any other thing. So then they release this one. So they stop releasing IPv5 because IP addresses with IP addresses only we can able to communicate. So obviously there must be worldwide acceptance is required. IPv4 is 32-bit in a binary size, means you take one IP address and convert into binary numbers, it is 32 binary number it is. IPv6 is in a binary 128-bit in size, means you take a one IPv6 and you write it in a binary format, totally zeros and ones are in a 120, zeros and ones you will get it. 128 bit in size. Okay. Next. So how many total IPv4 addresses? Like first IPv address, second IP, third IP, fourth IP. If you write all the IP addresses and you start counting how many are there, is 2 to the power of 32 IP addresses we are getting. 2 to the power of 32 IP address. It is around 4.3 billion IP addresses we are getting. In IPv6, you write all IPv6 one by one, first 0 to last IP address you are written. So it is 2 to the power of 128 IP addresses you are getting. It is 3.4 billion, billion, billion IP addresses you are getting, not single billion. It is called undecillion. So 3.4 into 10 to the power of 38 is your billion. Okay. So it is in a IPv4 is total number of 4,294 million 967,296. This is a IPv4 size. IPv6 size 3.4 into 10 to the power of 38 means you write 34. Just write 34. Put a 37 zeros. That is the bigger size. Okay. So compared to IPv6 is big in a size. Okay. This will be represented in a decimal format. IPv4 is represented in a decimal format. Like decimal numbers we are using. And it is represented in a hexadecimal format. Hexadecimal format. In a hexa numbers it is representing. Okay. Example 2000 colon 0. 123:1:1:1. Okay. Like this, it will be there. Okay. So I cannot write here with a mouse. So it is look like this one. Okay. Not always, guys. It depends. IPv6, so many other things also. Much again. Okay. Thank you. Okay, guys. The main part it is this 32-bit. We are taking 32-bit. This IPv4 is divided into 4 parts. Means each part is 8 bits. Total 32-bit binary is divided into 4 parts. Means each part is 8 bits. This 8 bits we call it as a octet. This 8-bit number we call it as a octet. It means we are getting 4 octets. In one single IPv4 we are having 4 octets. 4 octets. Okay, 4 octets. So the first one we call it as a first octet. Second we can call it as a second octet. Third octet. Fourth octet. Okay, like a it is separated by dot. It is separated by dot. Dot. Don't say point like a 192 dot 168 dot 2 dot 3. It is 4 octets separated by dot. 3 dots are there. Okay. I said octet. Octet means already said 8 bit. Means 8 binary bit. So 2 to the power of 8 is 256. Means if you write a 256 in number with a starting 0, ending 255. Means you count a number 0, 1, 2, 3, 4 up to 255. It is a total 256. Means each octet from 0 to 255 size only. Like you write a IP address 20 dot 300 dot 40 dot 3. It is a wrong IP address because this octet contains more than 255. It is wrong IP address. It is a wrong IP address. So compulsory each octet must be less than 255 or a maximum of 255. Okay. So you write an IP address. Yeah, meeting time 15 minutes. Okay. So here it is. That's what I have written up to here. Okay. So each octet is first octet called a first octet, second octet, third octet, fourth octet. Each octet size maximum 255, not more than that. Some people in a certain textbooks, what they will do it, they write these octets, to represent this first octet, second octet, to make it more easier. So they said it is WXYZ. The first octet is W, second octet is X, third octet is Y, fourth octet is Z. Okay. So first octet, second octet, third and fourth. But originally we should call this one only. This is the correct part. This is not wrong because it is used by different organization, different books. Okay. For make it understand easily. That's it. Not more than that one. Nonsense. Yeah. Uh, Okay, guys. So we lack of time. Actually, I like to type all these things. Each octet size is 0 to 255, not more than that. The total IP address range is the total IP address range is the starting 0.0.0 and the ending of IP address is 255.255.255. Means you start writing an IP addresses. This is the starting IP address. Then you have to go by one. 0.0.0.0, 0.0.0.0.1, 0.0.0.2, and you reach 0.0.0.0.254. Then it is 0.0.0.255. As I said, one octet size is 255. Think like this: 19. After 19, you are getting 20. How 20? 9 becomes 0 and 1 become 2. And 21, 22, 90, 29. Again 30. The same way, what will happen? 0.0.1.0 again. This becomes 0, 1 will be added. It continues 0.0.1.1 and 0.0.1.255, 0.0.2.0. Okay. It continues like this. We reach 0.0.255.255 finally. So all both are 255. Then it is become 0. This is also 0 and this is 1. This is 0. Okay. It continues like this. 1. Same last we reach 255. Sorry. We reach 1.255. 255. It is become 0, 0, 2, 0. Same way we reach finally 255, 255, 255. Then these are all become zeros and become 1. Okay. Like this, it's keep going 1, 0, 0, 1. Okay. Its dots are there, guys. Okay. So it is keep going. Finally, we reach the last IP is 255, 255, 255, 255. This is the last one. What is the first one? This is. What is the last one? This is. So this is the range of IPv4 addresses. Start with the 0, 0, 0, 255.255.255. Okay. This entire range, if you write one by one IP address in pen and paper and count it, so you will get this number. Okay. This is total range of IP addresses. Guys, understand?
Yes, sir.
Very good. We have hardly 5 minutes. Okay. Total IPv4 addresses divided into 5 classes. This total IP address ranges is divided into 5 classes. Okay, and it is based on the first octet only. The first octet only. Based on that, we can identify as well as it is based on that first octet only. Okay, the ranges are divided based on the first octet only. 5 classes: class A, class B, class C, class D, class C. I given an IP address to you and I said which class of this IP address. You have to look at the first octet, means the W portion, and check with this range and we can understand what class of IP address. So guys, class A, the class A, so first IP address anyway 0.0.0. So again we have to start with the first octet is 0. Okay. In a class A, if you write this first octet in binary, I write my first octet in a binary. Okay, because it's the first one, I keep my first most significant base as a same, and remaining bits become ones. Okay, they define like this. If you don't get this one also, no problem, guys. Important one is 0 to 127. This is 127, that is 0. Okay, you take a class B. So what is the next number of 127 is like this. Okay, this is second one. So then 2 bits. 1 0 is same. So we not can't remaining become ones, other parts. This is 128 to 191. This value is 191. This is 128. Class C. What is the next number of this one? 191 is a previous number. So 192 next number in a binary. And the range is first 3. 110. Remaining here 111. So it is 192 to 223. It keep goes for class D and class E. Class D, it is 111000. 1110 because D is a fourth one. Remaining become ones. It's 224 and it is 239. And this is 240 means 4 ones, 4 zeros. And these are all are ones. All are ones. 8 ones means 255 means is 242, 255. Okay. In this IP address, guys, this is R&D means research purpose. They kept reserved this class C. We cannot use this class C ranges for any purpose. It is R&D strictly for research and certain scenarios. Maybe some people. It's not for a network communication. Anyway, we are not using this. We can't assign class C ranges. Class D ranges for a multicast. What is multicast? Multicasting means you want to send a message to multiple devices, like certain protocols like a EIGRP, OSPF, or a certain operating system deployment. I want to install a OS in 100 computers at a time. Then I use a multicast addressing. These three are a unicast address. In our network communication, we can assign unicast addresses to our adapter. So you can see class A, class B, class C, unicast addresses we can assign to devices. We can't assign a devices is multicast addressing, and class C also we cannot assign. Also, we don't use this 0.0.0. We can't assign to our PC. It is reserved, used by certain services like a DHCP clients, default routing, yellow all representation. And entire 0 series we are not using. And 127.0.0 is a reserved IP address used for localhost or loopback address. Guys, I will explain this one specifically separately. I will explain. It is for self-testing, testing purpose, same device accesses purpose. We use this for IP address. In IPv6, it represent colon colon 1. Zeros we represent colon colon only. Okay, certain textbooks or certain Google searches, certain websites, clashes shows as a 1 to 126 or 0 to 126 because of the 0 series and 127 series. We are not assigning to any adapter. Okay, any device you cannot able to assign it. It is reserved IP addresses. Okay. Tomorrow we'll continue from here, guys, from IPv6 part, how IPv6 is some numbers, 1 or 2 points in IPv6, and also we'll continue from here. Okay. So
Okay, sir.
identification of class IP addresses and all. So for now, I'm removing these classes. We will identify tomorrow. Okay, so because my meeting time is over, otherwise I can finish this thing in 10 minutes. That's it for today, guys.